Hey guys, hope everybody's doing well. I'm going to be running through the practice test again, like I've done in the past. So feel free to kind of jump around any questions you may be stuck on. Use this to your advantage for the test at the end of this week. If you guys look down in the description, I'm going to put links or times actually for when I'm going to cover each problem. Feel free to kind of skip around if you'd like. And as always, you can come see me if you have any questions. Okay. Okay. So the first couple problems are doing inverse trig. I know it's been a while since we've done that, but they're not too difficult. Two difficult ones. So you just want to make sure you're paying attention to, the function that you're working with. All right. So the first one is inverse tan of tangent of 2 pi over 3. All right. So the first thing you want to do is you want to evaluate the inside. Okay. So tangent of 2 pi over 3. All right, and that's going to turn out to be negative root 3. So you have inverse tan of negative root 3. Okay, so now you have to ask yourself, okay, where on the unit circle am I going to get an angle that gives me tangent is equal to negative root 3? All right, and you have to make sure that you are in the right area, right? So remember that inverse tan is this side of the unit circle. Okay, so it's got to be between negative pi over 2 and pi over 2. Okay, so if you figure that out, right, the answer is going to be negative pi over 3. Alright, so when you do tangent of negative pi over 3, you get negative root 3. Alright, moving on to the next one, you have inverse sine of negative 8 pi over 9. Okay, now negative 8 pi over 9 is not on the unit circle, but essentially what you're doing is this is going to turn into a ratio. Okay, so you're going to have inverse sine of a ratio, and then your final answer is going to be some angle. Okay, so it's really not that important to us to figure out exactly what the ratio is. It's more important to actually figure out where negative 8 pi over 9 is and how that's related to the domain of inverse sine. Okay, so if you look at negative 8 pi over 9, right, it's somewhere over here. Okay, something that looks like that. Okay, so at that particular point, right, the x value is going to be negative and the y value is also going to be negative, right? So the y value is that ratio. Okay, so you have to try and think of, you want to kind of convert negative 8 pi over 9 into a spot where inverse sine is going to work, right? And remember, inverse sine is, again, the right side of the circle. Okay, so if you take that point there and you reflect it over the axis, right, you're going to be down here. Okay, so that point is going to be x, positive x, and then the y term, which is the ratio, will be the same. Okay, so what you want to try and do is change negative 8 pi over 9 to the angle over here. Okay, so if you look at this, right, that's negative 8 pi over 9, which is 1 pi over 9 away from the x-axis. Okay, so that means that this angle here, that's also going to be 1 pi over 9 away from the axis. Okay, and since we're going down, it's going to be negative. Okay, so what that means is negative 8 pi over 9 and negative pi over 9 both have the same y term. Okay, so what's going to happen is that you're going to have inverse sine of negative pi over 9 Okay, negative pi over 9 is in between negative pi over 2 and pi over 2. So your answer is negative pi over 9. Alright, so you just want to make sure that you're changing it, converting it to something that's in the right appropriate domain so that you can evaluate the function. Okay, so for the next one, again, you're evaluating it. So inverse sine of negative root 3 over 2 is negative pi over 3. Remember, it's got to be between negative pi over 2 and pi over 2. And then tangent of negative pi over 3 is negative root 3. Okay, that one's pretty straightforward. Alright, and then the last one, you have tangent of inverse sine of negative 4/5. Now, negative 4/5 is not on the unit circle. Okay, so this is one where if you're given a ratio, right, that's a ratio. If you're given a ratio that's not on the unit circle, you want to draw it out. Okay. All right, so since it's negative 4/5, right, that tells me inverse sine can either go up here or down in the fourth quadrant, right? Either one of those two. All right, so since it's negative, that tells me that it's going to go down here. All right, so you have some angle there. You know that this side would be negative 4, that side would be 5. Okay, and then the missing side would be 3. All right, so what's going to happen when you do inverse sine of negative 4/5 is that it turns into some angle, right? Some angle theta. And then when you evaluate tangent of that same angle, right, you're looking at the triangle and you're going to do opposite over adjacent. So negative 4 over 3. So that would be your final answer for that one. All right. Okay. So you're definitely going to have a couple proofs on the test. Using really any of the identities that we talked about. And like I said, you guys are going to have. I'm going to give you the sum and difference formulas as well as the double angle ones, but the other ones you guys are responsible for knowing. All right. So just remember for proofs, right? Obviously you want to try and do the side that is a little bit more difficult. Sometimes the level of difficulty is probably about the same, so it doesn't really matter which side that you pick. Alright, so for the first one, I think you could probably do the left side, but I did it with the right side. Okay, so I changed tangent to be sine over cosine. So I have 1 minus sine over cosine. Alright. And then what I did from there is I wanted to make a common denominator between the 1 and the sine over cosine, okay, which will require me to multiply the 1 by cosine over cosine. Okay, so what that's going to make happen is the 1 on the top is going to stay the same, and then I'm going to be left with cosine minus sine divided by cosine, I'm sorry. Alright, and then if you just do the division, right, it'll turn out to be cosine divided by cosine minus sine, which is what you have on the other side there. Okay. Moving on to the next one. I used the left side here. So what I did is I multiplied. I see that I have a factor of 1 minus sine on the top there. So what I want to do is multiply that factor by its opposite, right, which would be 1 plus sine. So I'm going to multiply the top and the bottom by 1 plus sine. Now I think you could probably do the other side as well. Just, my personal preference, I did the left side. Okay, so when you multiply that through, you get 1 minus sine squared divided by 1 plus sine times secant. Alright. Now you guys know 1 minus sine squared turns into cosine squared. Okay, and then you have 1 plus sine. Right? If you look on the other side, you need 1 plus sine in the denominator, right? So now you have to figure out how else can I make cosine to the third power. Right? So if I change secant to be 1 over cosine, right, what you'd be allowed to do is then bring that cosine into the numerator, which will make it cosine to the third divided by 1 plus sine. Alright, which is what you have there on the other side. Okay, moving on to the next one. So you want to show. For this one, I did the right side. So this here, right? That's your sum and difference, or that's really your sum formula for cosine. So on the right side, you're going to probably want to try and show that formula, right? In which then you can condense down. All right. So I know that I can change cotangent to be cosine over sine, and then I can change tangent to be sine over cosine. Okay, and then so on the left side I have one term, on the right side I have two terms. So I want to change the right side so that it's one term. So I need to multiply by a common denominator. So the first term I'm going to multiply by cosine of A. And then the second term I'm going to multiply by sine of B. Okay. Now because you have cosine of B times cosine of A, you can't make that cosine squared because technically they are different angles, A and B. If they were the same variable, then yes, you can make a cosine squared. But because they are different letters, right, that means that they're different angles, and you wouldn't be able to make that cosine squared. Okay, so what happens is that you get cosine of B times cosine of A minus sine of A sine of B over cosine of A sine of B. Alright, so now you have one term, which is good, and if you guys notice, your denominator are the same, right, on the left side and the right side. So now what I have to do is try and figure out what can I do with the top there. Okay, now if you notice, the top part is an expanded out form for the sum formula for cosine. Alright, so look on your formula sheet if you're having a hard time seeing it, but that's the sum formula for cosine. So when you condense that down, you have cosine of A plus B divided by cosine of A sine of B, which is what you need on the other side there. Okay? Right, so the cosine formula, the sum formula, right, is always cosine of the first angle, cosine of the second angle, minus sine of the first, sine of the second, which is what you have there in the second to last step there. So, you know, definitely try and be on the lookout for that one. Okay, now moving on to the third, or I'm sorry, the next one, the fourth one. Obviously we want to use the left side. Okay. Now this one, it might look pretty difficult, but it's really not. So this here is actually the expanded out version for the difference formula for sine. Okay, you have sine of the first, cosine of the second angle minus sine of the first, or sine of the second angle, cosine of the first angle. Okay, so if you condense that down, okay, you would have sine of 3x minus x divided by sine of 2x. Okay, so sine of 3x minus x is sine of 2x over sine of 2x, which is 1. And then you're done. Alright, moving on to the next one. So I use the left side here. Okay, so you're trying to show 2 cosecant of 2 theta. Right, now this is a double angle, right? Because you're multiplying theta by 2. Okay, so what you're going to want to show is somehow to get a double angle identity. Okay, and it should be kind of obvious once we get there. All right, so you have sine of theta over cosine of theta plus cosine of theta over sine of theta. All right, and then going from there, you want to get a common denominator, so you're going to multiply the first term by sine and the second term by cosine. Okay, so that's going to give you sine squared plus cosine squared over sine times cosine. All right, and you guys know sine squared plus cosine squared is 1. Okay, so yeah, this is again where you want to keep the other side in mind, right? So 2 cosecant of 2 theta, right? If you were to say put that in terms of sine, right, would be 2 over 2 over sine of 2 theta, right? Both of those things are the same thing, right? So I see that I have a 2 up here in my numerator, but I only have a 1 in my numerator on the left side, okay? So in order to do that, right, change the 1 into a 2, what I can do is multiply the top and the bottom by 2, right? You're still keeping everything the same, right? But it's going to help you, do the proof out. So now you have 2 over 2 sine cosine, okay? And what you should recognize from that is that 2 sine times cosine is your double angle identity for sine. So that's going to turn into 2 over sine of 2 theta, which then turns into 2 cosecant of 2 theta, which is what you have there on the other side. And you're done. All right. So again, you just want to keep everything the same, right? So by multiplying the top and the bottom, keeps everything the same there. All right, the last one there, I think that's the last proof. Yeah, last proof. I think we've done one very similar to this in class, so you guys can definitely look back on your notes for that. I'm going to use the left side here. All right, so I have sine of 3x. What's another way to make 3x? So that'd be sine of 2x plus x, right? And this is where I want to do my sum formula. So I have sine of the first angle, cosine of the second angle, plus sine of the second angle, cosine of the first angle. Okay? Now this is where you want to put, you want to change your sine of 2x and cosine of 2x. Okay? Both of those are your double angle identities. Okay? So sine of 2x turns into 2 sine cosine times cosine plus sine, cosine of 2x. Now again, you have options for these. Now if you look on the other side, they're all in terms of sine, so it's probably in your best interest to use the sine formula. The double angle identity for cosine, that's in terms of sine, which would be 1 minus 2 sine squared. Okay, so now you got 2 sine, that's sloppy, 2 sine cosine squared plus sine minus 2 sine to the third, if you just distribute through. Alright, so you're very close, right? So you want to change cosine squared so that's in terms of sine, right? So that is going to become 2 sine times 1 minus sine squared using the identity plus sine minus 2 sine to the third. Alright, so that's going to give you 2 sine when you distribute now. 2 sine minus 2 sine to the third plus sine minus 2 sine to the third. And then if you just combine your like terms now, you have 3 sine of x minus 4 sine to the third of x, which is what you needed on the other side there. Alright, so again, just when you're doing proofs, make sure you just take your time and you figure out exactly, sometimes like the first way that you do it doesn't always work. The second doesn't always work, right? So there's always multiple ways that you can do them. So okay, moving on to the next one. Right, we're trying to figure out cosine of 5 pi over 12. Now 5 pi over 12 is not on the unit circle, right? But I can figure out two angles that add up to be 5 pi over 12. Okay, so if I use, say, 2 pi over 12 plus 3 pi over 12, right? They both give me 5 pi over 12, and I know that 2 pi over 12 is pi over 6, and I know 3 pi over 12 is pi over 4. Now both of those angles are on the unit circle. Okay, so what I can do now is cosine of 5 pi over 12 is the same thing as cosine of pi over 6 plus pi over 4. So now all you're doing is your sum formula for cosine. So it's cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. Alright, so now you're just using the unit circle. So pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Minus sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. So now if you just multiply through, you get root 6 over 4 minus root 2 over 4. So your final answer is root 6 minus root 2 divided by 4. Alright, and the next one. Now this is, you want to try and condense this one. This is again another sum or difference formula. Alright, now I see that I have a product of cosine and sine, and then sine times cosine. Okay, so that tells me that I'm using the sine formula. Okay, because the sine formula is the product of the two. Okay, so if you figure out the function, it's a lot easier to then figure out what you have to do next. All right, now for the sine formula, if you are adding the two products together, like this one is, that tells me that you have to add the two angles together. Okay, so the first angle would be 4 pi over 5, and the second one is pi over 5. Right, so that gives you sine of 5 pi over 5 which is sine of pi. Now sine of pi is 0. So that would be your final answer there. Okay? So it's just recognizing which formula there is being used. Okay, moving on to the next one. Use the given information to find sine of a minus b. Okay, so sine of a minus b is going to be sine of a cosine of b minus sine of b cosine of a. Alright, now you're given secant of a and secant of b. Alright, so you need to figure out what sine and cosine are from those ratios. So you have to draw them out. Alright, so for the first one, it's between negative pi over 2 and 0. Alright, so that tells me that it's down here. Right, now the secant ratio is 2, right, where the cosine ratio would be 1/2. Right, so adjacent is 1, the hypotenuse would be 2, and that makes the missing side negative root 3. Alright, so if you do sine of a would be negative root 3 over 2, and then cosine of a would be 1/2. Alright, so you're just using the information that they give you to help you find the ratios that you don't know. And then the other one, you have secant of b is equal to 3 between 3 pi over 2 and 2 pi. So that also is in the fourth quadrant. Right? Secant is 3, or cosine is 1/3. And then the missing side would be negative 2 root 2. So sine of b would be negative 2 root 2 over 3. And then cosine of b is 1/3. Alright? So now that you have all the ratios, now you can figure out exactly what your answer is. Alright? So what I'm going to do is move this down here. Alright, so I have sine of a is negative root 3 over 2. Cosine of b is 1/3. Minus sine of b is negative 2 root 2 over 3. And then cosine of a is 1/2. Alright, and then you're just simplifying from there. Okay, so that gives you negative root 3 over 6 plus 2 root 2 over 6. So your final answer would be 2 root 2 minus root 3 over 6. You could have it the other way as well, negative root 3 plus 2 root 2 over 6. That's perfectly acceptable as well. Okay, and then the last part of the review is just equations. You know, we just did these, so these should be pretty fresh in your head. So you guys want to pay attention again to, you know, whether you have a multiple angle situation or not, and that should help you figure out the correct solutions. Now for these, you want to come up with they need to be between 0 and 2 pi. So you want to keep the interval in mind. Alright, so when you're doing these, you want to make sure you're solving for the function first, right? So that's going to give me sine of 2x is equal to negative 1. Alright, so you have to think, okay, where does the sine function equal negative 1? Okay, so that would be at 3 pi over 2 plus 2 pi n. Okay. Now, because it's 2x, we have to make sure that we divide our answers by 2. Okay, so your new general solution now is going to be x equals 3 pi over 4 plus 2 pi divided by 2 would be pi n. Okay, so your first solution is going to be at 3 pi over 4, and then you're going to add 1 pi to it to come up with any additional answers. Okay, so your final answer here would be 3 pi over 4, and then if you add 1 pi to 3 pi over 4, you get 7 pi over 4. So your two solutions are 3 pi over 4 and 7 pi over 4. Okay, moving on to number 2. I have the same function across the board, which is good. I should probably put everything on one side. Okay, so by doing that, you can now factor the equation, right? So it's like you have 2x squared minus 3x plus 1. So if you factor this properly, you have 2 sine of x minus 1, and then you have sine of x minus 1. All right, so you want to make sure that you're setting both of your factors equal to 0. All right, so then that gives you sine of x is 1/2. So that those solutions would be pi over 6 and 5 pi over 6. All right, and then the other one would be sine of x minus 1 is equal to 0. So where does sine equal 1? And that would be at x equals pi over 2. All right, so your three answers there: pi over 6, 5 pi over 6, and pi over 2. Okay, moving on to the last couple. So letter C, I see that I have cosine and sine function. So you really can't change the cosine function, but you want to change that. You can change the sine squared function so that it's in terms of cosine. Okay, so what you can do is then change that to be 4 times 1 minus cosine squared. All right, so by doing that, you now have the same function across the board. All right, so that's 4 minus 4 cosine squared is equal to 1 plus 4 cosine. Okay, put everything on one side, so you got 4 cosine squared plus 4 cosine, and that's minus 3 is equal to 0. Again, you can factor here. Okay, so if you factor that, you have 2 cosine of theta minus 1, and then 2 cosine of theta plus 3. Alright, so first factor, 2 cosine minus 1 equals 0. So where does cosine equal 1/2? Alright, and that would be pi over 3 and at 5 pi over 3. Okay, and then the second one, you have 2 cosine of theta plus 3 is equal to 0. So where does cosine equal negative 3 over 2? Alright, now if you guys remember, the range for cosine is actually from negative 1 to 1. Right, so there's actually no value on the unit circle where it equals negative 3 over 2. Right, it's not inside that range. Okay, so this would be a does not exist. Alright, so that tells me that my only answer is those two solutions there. Okay, moving on to the next one. I have sine of 2x equals root 2 times cosine. Okay. Now what I can do, right, is I can move everything on one side. So sine of 2x minus root 2 cosine of x is equal to 0. Now the reason that I'm doing that and not doing it like I did before is like when we had a multiple angle is because you have sine of 2x equals a function. Right? If it was just a number, then I would do it like I did a multiple angle one, like I did in part A. But for this one, because I have a function, I want to maybe use an identity. Okay, so I notice that I have sine of 2x, so that's a double angle there. So what I can do is I can change that to be 2 times sine times cosine. Okay, so by doing that, now I recognize that, okay, I have a common function or a common factor in cosine. So I'm going to factor that out, and that's going to leave me with 2 sine minus root 2 is equal to 0. Okay, so my first factor, cosine, where does that equal 0? Okay, so my answer for that would be pi over 2 and 3 pi over 2. And then I have 2 sine minus root 2 is equal to 0. So where does sine equal root 2 over 2? And then that answer would be pi over 4 and 3 pi over 4. All right, so if you have, multiple functions, again, you want to, maybe use an identity to kind of change it to be the same function or a common function where you can, factor it out. Okay. Now this one we kind of covered in class. It was a little bit difficult. So again, you have double angles going on here. All right. So if I change sine of 4x, okay, that's going to be sine of 2 times 2x. All right. Now the reason I'm not going to change the first sine of 2x is because I'm going to try and see if I can get a common factor with this second term here. Okay, so if I do the double angle identity for that one, sine of 2 times 2x, okay, that's going to give me sine of 2x plus 2 times sine of 2x cosine of 2x. Okay, so by doing that, I now have a common factor of sine of 2x in both terms. Okay, so what I'm going to do is I'm going to factor that out. Sine of 2x, and I'm left with 1 plus 2 cosine of 2x. All right, so this one you're going to get a lot of solutions because you have two now multiple angle functions. Okay, so the first one we'll do, sine of 2x is equal to 0. Okay, so where does sine typically equal 0? So that would be x equals 0 plus 2 pi n, and x equals pi plus 2 pi n. All right, now because you have a 2, right, you're going to take both of those solutions and divide them by 2. Okay, so that's going to give you x equals 0 plus pi n, and the other one would be x equals pi over 2 plus pi n. Okay, so both of these are your general solutions. Right, now to come up with your particular ones, it would be x equals 0. 0 plus pi is pi. Pi plus another pi is 2 pi, but that's not in our interval. Then the other one would be pi over 2, plus 1 pi would be 3 pi over 2. Okay, so those are your first 4 solutions. All right, now if you move on to the next one, or the other factor, you have 1 plus 2 cosine of 2x is equal to 0. So you have cosine of 2x is equal to negative 1/2. Okay, so you first want to figure out where does cosine equal negative 1/2. All right, so that's at 2 pi over 3 plus 2 pi n, and then the other one is 4 pi over 3 plus 2 pi n. And again, because you have that 2 there, you're going to take both of those general solutions and divide them now by 2. Okay, so that's x equals 2 pi over 3 divided by 2 is 1 pi over 3 plus pi n. Right, and then the other one becomes x equals 2 pi over 3 plus pi n. Okay, so now your particular solutions would be pi over 3, and pi over 3 plus pi n is 4 pi over 3, and then 2 pi over 3 plus pi n would be 5 pi over 3. All right, so those are your other 4 solutions. So for that one, you should be getting eight total solutions, right? And they're all between 0 and 2 pi. and the last one. So you have cosine of 2x plus 5 cosine of x equals negative 3. All right. Now I can't really factor this, right? They all don't have a cosine term in common or anything like that. But what I want to try and do is use an identity for cosine of 2x. Okay. I still want to make sure that I'm using the same function, but maybe I can get it to a higher power somehow. Okay. So if you can use cosine of 2x and then change it to 2 cosine squared minus 1, right? That's an identity, right? Now you have plus 5 cosine of x plus 3 is equal to 0. Okay, so if you put everything together now, you have 2 cosine squared plus 5 cosine plus 2. Right, now you have a quadratic that you can factor. All right, and that's all by using the identity there. So now you have 2 cosine of x plus 1 times cosine of x plus 2. All right, so your first factor, 2 cosine of x plus 1 is equal to 0. So where does cosine equal negative 1/2? So that would be at 2 pi over 3 and 4 pi over 3. And then your second factor, cosine of x plus 2 is equal to 0. Where does cosine equal negative 2? And like I said before, the range for cosine is just from 1 to negative 1, so negative 2 does not fit in there. So that does not exist. Okay, so these two over here would be your only solutions. Alright guys, so that's the practice test. Again, always feel free to come see me if you have any questions, and good luck. I'll see you later.